Okay, so today we're going to prove that the sum S of n of the first n terms of a geometric sequence is given by, so we have the formula S of n is equal to a sub 1 times 1 minus r to the n over 1 minus r. So let's go ahead and start this proof. So proof. Okay, so the first thing we're going to do is we're going to let a sub k be a geometric sequence. Okay, now we're going to look at the sum S of n. We know that this is just the sum from 1 to n of a sub k. So we can, of course, rewrite that as a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub n minus 1 plus a sub n. Okay? And of course, since this is a geometric sequence, we can rewrite this as a sub 1 plus a sub 1r, because the common ratio between the terms, right? Plus a sub 1r squared plus a sub 1r cubed plus dot 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 plus a sub 1r to the n minus 2 plus a sub 1r to the n minus 1. Okay? So now let's look at what happens if we multiply this sum by r. So let's look at r s sub n. That would be equal to a sub 1r plus a sub 1r squared plus a sub 1r cubed plus dot 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 plus a sub 1r to the n minus 1, right? Okay. And then, of course, plus a sub 1 r to the n. Now, let's look at this difference between these two sums. So if we look at S of n, right? If we look at S of n minus r S of n, okay? Well, what would that give us? Okay? So we have S of n, a sub 1. So that we would have a sub 1 here. But look at what happens with the other terms. A sub 1r minus a sub 1r, that's 0. A sub 1r squared minus a sub 1r squared is 0. A sub 1r cubed minus a sub 1r cubed is 0. And that trend continues all the way up to a sub 1r to the n minus 1 minus a sub 1r to the n minus 1, right? And then you can see all we're left with is a sub 1r to the n. So it's going to be s of n minus r s of n is equal to a sub 1 minus a sub 1 r to the n. Okay, so now let's do some factoring. So if I actually factor out the s of n on the left-hand side, so that'll give me 1 minus r. And if I factor out the a sub 1 on the right-hand side, I'll have a sub 1 times 1 minus r to the n. And of course, if I divide both sides by 1 minus r, that'll give me s of n is equal to a sub 1 times 1 minus r to the n over 1 minus r, which is exactly what we wanted to show, right? And of course, for it to be a geometric sequence, that r can't be 1. So that's why it's okay to do 1 minus r at the bottom. We wouldn't be dividing by 0.